All right, I'm going to cover, again, this is self-study video. I'm going to cover beta-arrestin effect on G protein receptor couple receptors. So what happens here is when G protein is activated, that's the initial step. G protein couple receptors activated. Leads to recruitment of G protein couple receptors kinases. And as we know, kinases phosphorylate. So the kinase would phosphorylate the receptor. This causes binding of beta-arrestin. Binding of beta-arrestin causes beta-arrestin prevents the coupling of receptor to G protein. Because of this, we're going to have a decrease in the effects of the agonist. Decrease in effect of agonist known as desensitization. Another effect of beta-arrestin, that's number one. Number two, beta-arrestin would removes some receptors from the membrane into the cell. Removing the receptors from the membrane into the cell makes it even difficult for some agonists or ligands to bind, because not all ligands are lipid soluble. So non-lipid soluble ligands would be prevented from binding to the receptors, because the receptors now will be in the cell. And lastly, number three, beta-arrestin causes degradation of those internal receptors. So it destroys, which means simply put, destroys some receptors, making it even worse. So just to recap, the receptor initially gets activated. Once they activated, for some reason, the recruit the G protein couple receptor kinases, and kinases phosphorylate the receptor. And once they phosphorylate the receptor, this makes it a better dwelling place for beta-arrestin. beta-arrestin attaches to the receptor. Once this happens, the coupling of the receptor with the G protein is interfered with, is diminished. This causes a decrease in the effect of the agonist or the ligand, whatever effect or message they will carry into the cell. For example, we discussed in the previous video stuff like activating the effector enzymes like the adenylate cyclase and phospholipase C. Those will not happen or will be decreased. Not only do they do that, once they do this, there's a desensitization, so they make the receptors less effective in transmitting the information into the cell. And the second effect is they also remove some of those receptors from the surface of the bilayer. And once this happens, molecules or ligands which are not lipid soluble, like large molecular weight molecules or charged or polar substances, will not be able to gain access to the receptors or their target receptors, which in this case would be inside the cell. And the last effect is that they degrade the internal receptors. So over time, the receptors that were removed from the cell surface would now be destroyed, making transmission of the agonist signals even more difficult to attain. So that's what I have for you guys. Just going to show you the board in case it helps, since I'm using my cell phone here. All right, thank you.